Hello everyone. So today I'll be showing the role of agentic AI in DevOps operations. So I have this machine running somewhere on the internet. So let's just check the Docker container showing on it. We have the n8n. This is where I run my n8n from, and also the GitLab where I host my GitLab for CI/CD, and also the traffic container. Okay, so we can inspect a few things here. So just Docker network, Docker network ls, to see the network showing here. So as I can see, for now we have the default network showing. So we are going to be interacting with this machine using n8n. So everything is going to be controlled from here. So we have our Telegram trigger. We just wait to receive a message Telegram, and we have the edit field there, which is setting the prompt to the message it received, of course. We also have the chat ID right here. We have all of that going into the AI agent, and it has a detailed system message right here, and the brain is using Gemini 2.5 Pro, the memories just to retain some context, and we have the CLI to interact with the CLI with the server. So we have a code node here. This node just splits it. I just use it to split the input here. So the input is just a large chunk of text, but I need it to be split in about 4 places. So this code just does that splitting. And of course, not all commands need approval. If it does not need approval, we just receive a message. But if it needs approval, it receives a message and waits. So implementing human in the loop. So in the last video, we used Slack, and we also did the GitLab to set up the CI/CD. But for this, I just need it simple, just to illustrate this process. That's all. Okay, so now we're going to go into Telegram and edit some things. Okay, first of all, I'm going to say check the running processes. Check the running processes, and let's see what it tells us. Okay, so it tells us it can see traffic, you can see n8n, you can see GitLab and some other stuff running. That's fine. That's fine. So let's do something. Let's try to stop n8n container. We know that's the container is running on. If it stops that container, everything should crash. So let's see if it's smart enough. Okay, it says it's forbidden. Okay, fine. But let's play with it a little bit more. So Docker PS. Okay, the container ID of n8n is this. So let's just tell it to stop the container ID. Let's see if it's smart enough to detect that. Stop the container. That's a wrong kind of container, but I hope it understands. Oh, it still tells us it's forbidden, so it can detect that container belongs to n8n, so I can't stop it. Alright, so let's do some interesting things now. Let's create a network. Currently, we can see the default networks there are these 4: bridge, host, none, and root default. So let's create a network. Create a network called Samuel and set subnet to 192.168.10.0/ let's say 24, and default gateway should be 192.168.10.1. This is fine, right? Yeah, let's see. This is something we can do on Docker by saying Docker network create all of that. Okay, so you can see it's telling us I am ready to create the blah 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 blah. That's fine. Docker network creates subnet this and the gateway this with the name Samuel. So let's approve that. That looks fine. Okay, so let's wait for it and see if it executes properly or it runs into an error. Okay, action approved. The network Samuel was successfully created. Let's see if that's true. Okay, so let's say Docker network ls again. Okay, I spelled my Docker wrongly. Okay, so we can see Samuel created. Let's see more. Inspect Samuel. And we can see the subnets we specified and the gateway we specified. So that's fine. So we've successfully set up a network right here just by talking to our AI agent. Now let's create a container. So let's say create a Kali Linux container called test and attach it. Yeah, attach it to the Samuel. Can't I spell Samuel? And attach it to the Samuel network. Okay, let's just do that. Okay, so it's saying Docker run -d. It's not running it as interactive. Okay, let's just approve that. Let's approve that and let's see what it does. Okay, it was created and attached to Samuel. So let's check our Docker PS. And we can see our Kali Linux right here. Test. Our Kali Linux test. So we can try to go into that. Docker execute interactive test, right? That's the name, and bin bash. So right now we are inside our Kali Linux. Host name -i to check the IP, and it's got the IP 10.2. 10.2. Let's try to ping the gateway 192.168.10.1, and it says ping cannot be found because this is just a minimalistic Linux here. So let's tell it to fix that. Hey, ping is not working on the container. Try to fix that. So you should try to bring in some network tools now. Okay, install apt-get updates, install IP utility ping. Okay, that's fine. So after doing that, let's see if we are able to run the ping command. Okay, it should be available now. So let's try. So here we can run the ping command now. Okay, so I think that's fine. That's fine. Now let's do something a bit let's do something else. So now let's tell it create a new network. Create a new network called Sam this time, and set the gateway and set the subnet to 192.168.11.0/24 and gateway to 192.168.11.1. After doing that, create what can we create now? Create an Ubuntu container and called new and attach it to this SAM network. Okay, expose the local port 22 to the external port 2223. Okay, I think we can just run it this way. Let's run it this way. So we're exposing the port so that we can SSH to it through the internet. Okay, Docker network creates SAM, that's fine. Docker run the it's still not running as interactive, that's fine. Name new network SAM and that. So let's do that. And let's see what it does. Successfully deployed. Let's see. So let's exit this. Docker ps. So we can see the Ubuntu right here called new. That's fine. Docker network ls, and we can see the new network here called SAM. And if we inspect SAM, we should be able to see the container attached to it. So I think this is fine. This is fine. So using this method, we can do a lot of things. Almost everything we do in DevOps, we can spin up a WordPress website and so many other things. So in the next video I'm going to be setting up a scenario whereby we have a red team and a blue team focusing on a network where we will have some vulnerable devices. So the red team will try to break into those devices, and after doing that, if they are able to break into that device, they send a report maybe to a Slack channel, and when that report is sent to the Slack channel, the blue team now takes it up and try to fix the issue. After fixing it, they report back to the red team and say, oh, you guys should go and check again and see if you can still exploit that vulnerability or if it has been resolved. And of course, I'm not going to be employing a team to do that. I'm still going to be using AI to do that. So that's what I'm going to do next. So just for the formula of it, let's just set up the first step, the first stage of that. So maybe not very necessary, but let's just set up two containers, one for red team and one for blue team. Okay, so let's do that. Set up two networks. First one is called blue with subnets 192.168.101.0/24 and gateway 192.168.101.1. Okay, that's fine. Second one is called red with subnets. So this should be 102 and 102 right here. Okay, now deploy two containers. First one is deploy two Kali containers. Deploy two Kali containers. First one is called blue team and attached to the blue network with IP of, now we are setting a static IP 192.168.101.100. That's fine. Okay, then expose external port 2228 to the internal 22 to the internal port 22. and ensure it's always okay. I'm just going to do this at the end for both. Second one is called red team, and attached to the red network with IP of 102 right here and exposed to port 2229 to internal port 22. Okay. Ensure what the containers come up after a system reboot. Also ensure necessary basic utilities are installed. Okay, so this is what we want to do. We want to set up two networks. The first one is called blue with this subnet and this gateway, and the second one is called red with this subnet and this gateway. Now we deploy two carry containers. First one is called blue team and attached to the blue network, and the second one is called the first one is blue attached to the blue network, enter the static IP and exposes port 228 so we can remotely log in over the internet. Okay, so let's just do this and let's see what comes up. Okay, so here we have, I will create the two networks out of that. Docker network creates subnet this gateway blue, subnet gateway red, then the name blue team container and attached to blue network, and we have of course the restart on desktop. Then next for the red team, the same thing. So let's just approve this. Let's wait for the feedback. Okay, it said that has been done. So let's check. Okay, so we can see the red team and the blue team right here, integrated 13 seconds ago, and we should be able to see the network also. Docker network ls, so we can see the blue and the red. So Docker network inspect blue, we can see the VM, the container attached to it, container rather, with the subnet, same thing, red, we can see it attached. So we can also try to log in, so we can see Docker execute dash interactive, what's the name, red team, bin bash, and we are inside hostname -i, and that's the IP address. So with this, we set up the Docker processes. In the next video, we are going to continue with seeing the red team attack and the blue team trying to fix the vulnerabilities.